Question 4 provides you with the results of a survey, and in part A you're very much guided down the road of chi-squared testing here, because it asks you to state H0 the null hypothesis and H1 the alternative hypothesis. So looking at the fact that we've got on the rows here in effect voting intention, and on the column headers here we've got the age. The null hypothesis will be something like voting intention is independent of age. So whether or not they oppose the reduction or favour the reduction is independent of age. And essentially the alternative hypothesis will be voting intention is not independent of age. So words to that effect. In part B then we are asked to write down the number of degrees of freedom, and remember the formula here we use is the number of columns here, which is going to be 3 minus 1, multiplied by the number of rows, which is 2 minus 1. So that will give us 2. So there are 2 degrees of freedom in this table of results. For the next part of the question, we are asked to show that the expected frequency of those between the ages of 26 and 40 who oppose the reduction in the voting age is 21.5. So on the table of results, we're looking at those between the ages of 26 and 40, which is this column, and we are looking at those who oppose the reduction, which is this column here. So in terms of trying to find the expected frequency, we say what proportion of the population are in this age bracket? And we know that 35, which is the total here, out of the total of 130 are in this age bracket. We then multiply it by the proportion of the total population who oppose the reduction, which is this total here, so 80 again over 130. And then we multiply that by the total population, which is 130. Now you can see those two will cancel out, so most of you would have just used this formula here, 35 multiplied by 80 over 130. And if you do that, that gives you the answer of 21.523 sig figs. Part D then is a section which really requires us to be au fait with using the calculator to find the chi-squared statistic and indeed the associated p-value for this test. So we should be getting a grip of this by now. We're going to start off by going to second function and matrix. We are then going to select 2 by 3 because we have got 2 rows and 3 columns. We're then going to enter in all the data for this. And once we have done that, we are going to click the stats button, and we are then going to go across to tests, scroll down to C, which is the chi-squared test, and that is going to give us a value of 10.3 and a p-value of 0.005, and you can see here the degrees of freedom confirm what we were asked to work out earlier on in part B. Part E then says determine, giving a reason, whether the null hypothesis should be accepted. Well, in the question we have been given both a critical value, so we know that the critical value is 9.21, and we're also told that we're testing at the 1% significance level. So there's 2 ways that you can do this. The first way is using the critical value, and to do that we need to take the chi-squared value, which is 10.3, and we can see that because the chi-squared value is greater than the critical value, we reject the null hypothesis. So wherever the chi-squared so if we just generalize this, wherever the chi-squared value is greater than the critical value, we reject H naught. The alternative, rather than using the critical value, we could use the p-value. And if we use p-value, as I mentioned on the previous paper, it confuses matters just because it's the other way around. So if you're looking at p-values, the p-value we've got here, remember this, you need to interpret this as a percentage. So this would actually be 0.57%. So you need to multiply by 100 to get it into percentage. So this is 0.57, which is less than the 1% stipulated here. Now when you're looking at p-values, your value has to be less than the probability in the question for you to reject it. So again, we can generalize that and say if your value of p is less than the level of significance, then you will also come to the same conclusion, which is to reject the null hypothesis.